Hi, everyone. So thanks all for being here. My name is Sam. I'm a software engineer. I work mostly on big data projects and machine learning, this kind of stuff. And I'm very passionate about all things distributed computing. So I'm going to talk about Mesos. Now I'm going to try not to dive a little bit into what Mesos is into details, but instead we're going to stay a little bit on top to have a higher view and how it works. And we see some examples if it works. Okay. So I think all of us here are software engineers at some kind, and there's a trend that we see that's been going on for quite some time now, is that whatever application that we are writing today tend to be distributed by nature, whether it's a simple web application that at some point it's still going to span around distributing that application into multiple nodes. So there is this interesting paper called "There's not just getting around it, you're building a distributed system," which is true. And as we all know, distributed systems are not the easiest thing to build. You always start out as being small, but once you're trying to scale that, you run into a lot of complications. For example, what we have is that you tend to have a cluster, whether it's on-premise or in the cloud. This is where you want to run your applications. So what you start out, you want to run the first application. You scale that out by adding multiple kind of applications. So you want to run a web application here. The example runs Akka with Play. You want to run as a CI server, you run Jenkins. You want to run some Hadoop, some big data workloads, you use Spark and Hadoop. You want some real-time things, you run Storm. You want some caching, you use Redis. And your cluster is statically partitioned, which is kind of hard to scale at some point. So what you tend to have is that, for example, you have some node failures. Here, your Hadoop nodes, which happens all the time anyway, fail, for example, you're losing some nodes. And how are you going to recover that? So you're going to lock your cluster for some time, add some nodes, and then restart your jobs as it goes on. And in the same time, you can have some maintenance failure. For example, and I have to cut off all my Redis nodes and work again to make it work. And this is very hard. So at some point, developer tends not to think about this kind of stuff. They leave that into the hands of operation people, of DevOps, of ops guys. But that's not exactly how we're trying to build today, because this increases a lot of complexity. You have more machine to provision. It's getting harder and harder to handle software failures. Your number of machines keeps growing up exponentially. And like I said, when you're a developer, you try not to think about it. You just want to push as quickly as you want your application into production. And planning for failure maintenance, that's really not something that you turn to work. So most of the time what we do is that you revert into the cloud or use a platform as a service and so on. And another problem with statistic partitioning is that, for example, you're running multiple applications. What you see on the amount of resources that you are using is that they're not very optimal. You're not using your cluster in a very optimal way. You have a Play framework that has some spike, but most of the time it doesn't use the whole CPU, the whole memory as much as it could. The same goes with Redis, with Hadoop. You have some spikes when your jobs are running, and then they stay flat. And all your machines that are actually running there are just staying idle most of the time. So how can you work with that? But as you see in this graph, you have this kind of not very optimal usage of your resources, what you want to see later on. If you couple them together, you could see something like this. And you have a much more efficient way of using your resources. You can try to pull them together. But this comes at a cost. You can't just say, I'm going to run my web server inside my Hadoop cluster. It's kind of hard to do these kind of things. So you go on. How good guys, like always, when it comes these days, Google comes out with an idea. They have this thing inside Google called Borg. I mean, that's an official name. Everybody calls it Borg except people who work at Google anyway. So That's that's the good thing. But the nice idea is that they came out with a paper called Omega, which described a little bit what Borg was and how they tried to evolve into that thing. So the main idea was like, instead of seeing your cluster like in the beginning here, as having multiple nodes separated there, they bundle them into seeing it as one big computer, as a single pool of resources. We get into that a little bit in detail, but I just want to go back to my slides. Yes, so they bundle this machine into a single pool of resources. And what they do is that when they're running when they used to run MapReduce jobs, they throw them into the cluster. And between computers, the developers actually don't think about the distribution behind. You just like calling a simple API when you're running your data. And that saves costs. And in the Omega paper, they describe that doing this kind of operation by pooling all the resources, they saved the cost of at least one entire data center. And it doesn't come, like I said, as free, because you tend to centralize all your resources, and that's a possible bottleneck. And another problem is that sometimes you don't run the same kind of workload. You want to run some real-time workload, so you have some continuous stream processing. You want to run some long-running queries into databases. You want to run some long-running job like MapReduce. So that's not very easy that you have to think about this kind of problem if you want to pool all your resources. So let's come back to static partitioning. What you had usually with static partitioning is that you have multiple nodes that span across your machines or your cluster. And for each application running on those nodes, you have a coordinator, whether it's a master or something else. And what you want to do with Mesos, which actually is inspired by the Google Borg system and later on by the Omega paper, is that instead of having all this coordinator here, it's like it solves this problem like in many programs in computer science. You just add a level of indirection. So instead of actually calling your coordinators on top, what Mesos does is that it stands up in the middle as a single layer, provide APIs into your coordinators to work. We see a little bit how it works in detail. So here, instead of actually calling your nodes, thinking about the distribution, you give that responsibility to Mesos to take care of that. What you want to do, what you're actually doing, is actually interacting with Mesos. Mesos is going to go down into all the slaves, take all the resources and provide them to you so you can run your application. And the advantage of doing something like this is that you can run multiple workloads. Mesos helps you actually work batch workloads, so Hadoop, big data things, Spark. You want to run long-running services, like a web application, like a continuous integration system with Jenkins. You want to run some storage systems. You have people who actually run Cassandra or MongoDB inside of Mesos, which for me is still crazy, but still they do that. And you can think about anything. As long as it's distributed systems, you can try to run a lot of things. And what Mesos wants to do, the hard problem that it's trying to solve actually, is to provide all the properties, to provide a way to solve all the problems that come with building a distributed system, whether it's handling failure detection, thinking about how you distribute your tasks, how you track them, how you monitor them, how you manage all your resources down below. And another thing that Mesos try to give you is actually to think about your resources at a lower level, as a fine grain, not just thinking as a machine, but as a CPU, as an amount of RAM that you want to have, that you need to run your application, and as an amount of networking that you want to use, how to isolate those things. That's how Mesos want to do. And you have many systems that do that, but the difference with Mesos is that it emphasizes about scaling to thousands of nodes. So in the many companies that actually use Mesos today, many of them actually run Mesos on multiple nodes. Not when I say multiple, it's not hundreds, but thousands of thousands. The big user of Mesos today is Twitter. And Twitter uses Mesos at something like 5,000 to 6,000 nodes, where they run all the services, all the Hadoop jobs, all the Storm, all the things. So they're the main contributor today. Same goes with Airbnb, who doesn't run Mesos inside an in-house cluster, like an in-house cluster, but instead on EC2. So they have the EC2 layer, and on top they have Mesos that runs all the resources. And by bundling all these resources on top of Mesos, what they actually do is to save a lot of money, to save a lot of cost, and an easier way to manage all the resources. So, like I said, what you want to do, whether I wrote here as physical machines, but you can think them as well as just being virtual machines. So you have all your machines, you bundle them, and you see the data center as being a single computer. That's a marketing term today, but that's how the main idea stands. It's actually building a data center, it's not being an heterogeneous actually set of different nodes where you want to run different workloads, but as being one single computer that provides you the same semantics as the way you run application on a single node. So a little bit here, let's before I go on, what the Mesos looks like. Let's switch a little bit. So I try to build a larger Mesos cluster. So I'm going on Google Compute Engine here. I have a development Mesos cluster. It runs on 3 nodes here, for example, and I've launched it here. Where is it? Okay, the smaller one. Okay. Everybody's saying, okay, we're good. So here I have Mesos. This is the main UI of Mesos. So what it gives you is that you can see that I've run some tasks on top of it. We'll explain a little bit inside how it works down below. You have some tasks here. You have the amount of resources that you have on your cluster. So it says you have 6 available CPUs. You have 19 gigabytes of RAM that you're trying to provide. It gives you the tasks that you run. I've staged 252. Unfortunately, almost all of them failed, which is not cool. I have 3 slaves. So the slaves are my nodes. I have 3 of them who are here. And I can see the kind of job they ran. I have frameworks. I'll explain a little bit later what are frameworks. And here I have 2 frameworks. You have the name of this one. It's called Marathon. And you have another framework called Chronos that's running on top of this Mesos thing. So this is what Mesos looks like. So I can try to log into one of the master node. So yeah. Here, for example, if I try to do some Mesos state, give me exactly what I have on the UI, but as a JSON thing. So I can query the API, and you can try to see what's running here. I have no task running for that moment, so you have a lot of things. So this is what Mesos looks like. This is a simple explanation of Mesos, and this is what you have as command. And we see a little bit later what do all these things mean. So let's go back to the presentation. So now let's dive a little bit inside Mesos and see how it works inside. So Mesos follows a typical master-slave architecture. So what it has is it runs, you can run Mesos with one single master, but that's not recommended, especially in production, because if your master fails, you're losing all your resources in your cluster because the master does most of the job in Mesos. So what you try to do is actually you have a set of masters, a master which is replicated, and you have a zookeeper as a way to do leader election. So you have 3 masters and a zookeeper that use the zookeeper quorum to elect a leader, and the zookeeper is used as well to do election leader discovery within zookeeper. And you have the master below, the slaves below. Those slaves are registered with the master, and the master runs something called a framework. We'll see a little bit what the framework is, and the slaves run the tasks. This is a higher view of what Mesos looks like. So what is a framework? Like you saw here, I have Hadoop scheduler, MPI scheduler on top. Here I have Hadoop scheduler, MPI scheduler, and I have Hadoop executor, MPI executor, and so on. For those who don't know MPI, it's a big data old age, like if you want to call it this way. It's a way to run distributed computing on clusters. So a framework is actually the parts of your application that helps you run it on top of Mesos. So it runs distributed application from Mesos. And it has two components. You have a scheduler. A framework scheduler is the program that interacts with Mesos. What it does is actually it books resources with Mesos. Mesos offers the scheduler some resources, and it launches the tasks that you want to run within in your slaves by going through Mesos. And the executors are actually the program that's running the tasks in the slaves. So the scheduler most of the time is run on top, inside the masters, and you run all the low-level details within the executors in the slaves. And Mesos provides an API to build your own framework. It can be a little bit hairy, but you have SDKs to do that today. You have a C++1, Java, Python, Scala, Go. You even have one in Haskell and another one in Clojure. I mean, you have a lot of them actually. Just go on GitHub. You're going to find many of them. And you have many programs. Like for example, here, these are programs that actually have frameworks already implemented to run on Mesos. For example, I have Aurora. I'll explain a little bit what it is later on. You have Hadoop, you have Kronos, you have Jenkins. Jenkins comes with its own framework to run them on top of Mesos. You have Cassandra, Elasticsearch, Storm, Spark, and so on. You have a lot of them. It seems like every week someone is coming up with its own framework as a way to run them easily on top of Mesos. So we're going to dive on how Mesos manages resources. So usually what you have with what we call cluster managers as a generic name, what you usually have is actually a static way of defining the resources that you're offering to your nodes. Mesos goes the other way. You don't book your resources yourself, but instead, Mesos try to push the resources to your application. So it's something called resources offers. So it offers some resources here, which you have on the right, you can have, on your left, sorry. Yes, you can, on the right, you can have your masters. Your master offers some resources. And those resources are, like I said, the number of CPU that you want, the quantity of RAM that you want to run, and the name of the host where you want to execute them. And what resources actually are, they are a snapshot of your resources at the moment where Mesos is running multiple tasks on your cluster. So basically, it has a view of what's actually running below your cluster, inside your cluster, and it judges by the kind of resource that you already have, what you can need. So it has a deterministic way. It doesn't make you wait, actually. If you ask something like 8 CPUs and 16 gigabytes, but it only has 4 CPUs and 4 gigabytes, you're going to offer you something. Either you take it or not, that's up to you. That's up to your scheduler on how you write it. So let's see the protocol on how Mesos try to make it work. So you have a master, a Mesos master. Then you add a slave. Okay, that's the process where you're building your Mesos cluster. A slave register with your master, go through Zookeeper, that's half a job, and then you have all the things. Then you want to run an application. Well, like I said, an application is run by a framework. So a framework has a scheduler and an executor. The scheduler runs on top inside the master, and the executors are inside the slave. And what Mesos does, it gives you an offer. Okay, here's what I have. I have 4 CPUs, I have 4 gigabytes of RAM. Do you need them? And if the scheduler agrees, it launches tasks, but it doesn't launch the task itself. Instead, it goes through the Mesos master. The Mesos master is going to run the task through the slaves. The slaves are going to tell the executor, okay, take this amount of resources and start some tasks inside your executors. And once the tasks are launched, it gives back some updates on how the execution is going on, so on. It keeps going on and pull them. And you go all the way back, all right, all the way back into the scheduler again. So the scheduler, the Mesos master, all are aware of how your tasks are being executed inside the cluster. So a Mesos slave looks basically like this. So you have, like I said, in the master you have the scheduler, have a lot of things, but let's focus a little bit on the slave. So this is how it looks like. You have the slave, you have executors, and executors are running tasks. So you can have multiple executors because in the one slave you're running a lot of things, multiple executors and multiple tasks for different kind of job. This task, the first one can be a Hadoop executor running Hadoop jobs, Hadoop tasks. The other one can be a web service being run using Play or Aka or something. And these are Linux containers. Because what Mesos does is that the quantity of RAM, of CPU, of the networking that you have, it bundles them inside one container, and that container runs those elements into each slave. So a slave has a lot of Linux containers that are running your jobs. And Mesos started out using Linux container for a while now. At the beginning in 2010, they started with full-blown LXC, like many projects, but LXC has a lot of dependencies and a lot of things that you actually don't need, really. So they went from LXC and actually started just using C groups, which are control groups. And Linux control groups, actually, those are the things that provide isolation for CPU, for memory, for disk, and in 2014, which was last year, they added namespacing. And namespaces helps you isolate your networking. So using C groups and namespaces, well, in Mesos, where what you have is a full isolation. So a view of the Mesos slave looks exactly like this. So you have a Mesos container, which run an executor and a task. You have a CPU isolator, a memory isolator, a disk isolator, and those run containers. These containers are C groups where you have your executor and your task being run inside it. So I've talked about Linux containers, said, oh, what? LXC, what's this thing? Talked about C groups. And I'm sure a lot of you are wondering, why did I say that? Because unless you've been hiding under a cave for the past 2 years, or you haven't been here for the past week, everybody has been talking about Docker. So yes, I'm not saying that all these people look like Hodor, but still, everybody's like Docker, Docker, Docker. So yes, since Mesos is running C groups and namespaces, well, Docker does the same thing. Docker started out using LXC. They say they use the LXC, then they went with libcontainer, which actually does the same thing by using control groups and namespacing, which is way convenient to actually run your application than actually using full-blown LXC. So last August, they added the native support for Docker containers in Mesos. You didn't have that before. What you had to do is actually use something like an external containerizer system. So what you had is like you had a program called Demos. Demos would run Docker containers somewhere and push them inside your Mesos container. But now what you have is actually alongside Mesos containerizer, you have a Docker containerizer. So what you have, you can run in the same place Docker containers and some random Mesos containers that are not supported by by Docker. And one thing about Docker container is that you can run them not just as a full container, but you can run them as executors as well. You can run them as tasks. So you can have a container and say, take this container, run this container as tasks. You can have the dependency graph between your containers to be run inside Mesos. It's a bit hairy to code and to work around it, but it's something that you can do. Actually, many people are writing application or porting some application into that, doing these kinds of things. So we've seen that Mesos uses Docker containers, C groups, and Mesos itself is a distributed system that's trying to manage distributed systems. So that comes with a lot of problems, which one of them is fault recovery and high availability. So like I said, the masters themselves use Zookeeper as a way to do leader election. So if one master fails, Zookeeper will restart an election process to find a new leader. But if one master dies, and since the masters are trying to log all the execution of each task in your slaves, what the master needs to do, if one master dies, the next master needs to know what happened between your thing. You don't want a new master to be spun out and actually start from scratch, because you're losing a lot of data, especially if you're running very sensitive things. So what Mesos has is something called a registrar, which is a replicated log, where it logs everything. But since that log is replicated between all the masters, they use multipaxers to have a coherent view, so to have consistency in their data. It's like having a database, but a database that's formalized like a log. That's how the master does the fault recovery. So if a master dies, another one comes up, it just stars out whatever data it has, and it's trying to keep a coherent view of all the data running inside the cluster. And the other thing is that what happens if you lose a slave? Well, you have a slave recovery mechanism as well inside Mesos. So if one slave dies, well, the tasks that are being run inside your slave will keep running, or at some point it's not going to stop you from being, it's not going to stop the system itself. So how does it do that? Well, it checkpoints all the data between your slaves inside the local disk. Instead of, you already have the masters who have a data from what's being run inside your slaves and all the cluster, but each slave has a disk. I mean, it's a machine. So what it does is that every element checkpoints all the available data. It logs that inside the local disk. So if the master fails, well, it already has a view of what's being run there. And when the slave recovers, you start a new one. Well, it just recovers from the checkpointed data and keeps churning on. So that's a simple way by doing a checkpoint. Now, some people want to move that into having a database where you can write all this data and to have something, not just with disk or push them somewhere. There's an API for that, but for now, Mesos actually does checkpoint the data into the local disk of the slaves, and then respond to the slaves, and they just recover from the checkpointed data. So, like I said, you have a lot of things. You have a lot of applications today that already have frameworks that are being written over there. And I said you have all these languages and SDK that you can do, but writing a framework can be very complicated at times. And especially at the beginning, Mesos, like many cluster managers, were not thought to run long-running services like websites or web applications or things that do not stop. At the beginning, Mesos was built to run things like Spark, because, for example, Spark was a demo application for Mesos. Now it has become something of itself, but at the beginning it was just an application that will do some data processing like Hadoop does, like a multiple job, to just demonstrate that the Mesos cluster manager was working. So now it's being spun out as being something in itself. So what you want to do sometimes is actually have a generic framework where you can push all your data, all your applications, sorry, not your data, but where you can run all your application. So basically having something like a platform as a service, but on top of Mesos. There's a project for that. We have two, actually. Here I'm going to talk about one of them, which is Marathon. Marathon runs long-running services, so that's what it does. We have another one, which has been built by Twitter, and it's in the Apache Foundation. It's called Aurora. They basically do the same thing, but just that Marathon's model is way more advanced, and it has more features than actually Aurora does, at least at the moment. So what is Marathon? Well, it's a lot of things. I said it's like a platform as a service, but there's more to that. It's a generic Mesos framework, so you can run long-running services. You can even run in Marathon something like Hadoop jobs or Spark. For example, I use Marathon to run my Spark jobs. And you can see that as an init day. So that's something that launches your process. That's, you have initd inside Linux, and into your cluster you have Marathon that behaves like your initd to launch your process. And what's nice about it is that you can just push any Linux binary. For example, you have a Tomcat application, you bundle it into a container, and you bundle them and tell Marathon to launch it just by a command line. Marathon will spin out some nodes and slaves that do all the work inside Mesos. And it's also a way to supervise all your processes inside your cluster. But like I said, you can also see Marathon as a private platform as a service, because what it provides is something like service discovery. For that, it's using something like HA proxy, but I don't use that one. I use etcd instead because I think it's way simpler, or use DNS. And oh yes, it provides a self-service REST API for deployment. Sorry, there's a typo here. But yes, it provides self-service REST API for deployment. If you want to deploy an application to Marathon, it's just like describing a JSON thing, do a curl or a REST call, and it's done. It has authentication. With Marathon, you can be rack aware. You can say, okay, I don't want you to run this application on this type of node. You can specify where you want to run it. Or you can say, okay, run it somewhere different. You can do the same thing with Spark. For example, Spark has just a side note, Spark in Mesos runs in 2 modes. You can run it like as running a small tasks, like by default Mesos does. But since Spark does all the job in memory, running that as small tasks has an overhead, especially for starting your jobs. If you have big jobs, instead, what you want to do is have all machines that are actually working just for Spark. So you can do the same thing. That's the coarse-grained mode. You can say, okay, I want you to run my application not as a set of tasks and container, but inside one container in one slave machine. You can do that as well. Marathon helps you do the same thing. And it provides self-discovery, load balancing. I think I've said all of that. So, for example, what you do, like I said, it has a REST API. If you want to run an application from Marathon, is that you just push a post, you do a post request inside Marathon. Marathon calls with Mesos, and dispatch all your application on the number of node that you want. If you want to run another application here, well, you do the same thing. Instead of running Rails, well, I'm going to run a Play application as well. It does the job for you. With Marathon, you're not interacting with Mesos. You're just interacting with REST API with something different. Here, Mesos just behaves like a way to dispatch, to deploy your application, and as a way to manage all your resources. And this is what it looks like. This is the REST API, the Marathon REST API. So you just do a post. V2, you provide a JSON file, and here it's like an IPython notebook, and then boom, you provide the option, and it does all the work for you. So, for example, here, if you want, before I go there, well, if you want to update your deployment, for example, by adding more instances into your deployment, well, you just do a patch of your instances. You want to add more instances, well, you just say 4 applications. You want 4, well, you push this element, and there you go. So how does it look like? Like I said before, here I have Mesos, and I have all these failed tasks that went there because I have a problem with Zookeeper this morning. And here I have Marathon. Like I said, here I have frameworks running. It tells you now, you can see what it means. I have a framework here. This framework is Marathon, and Marathon has 0 CPU, which means that there's nothing running there. And here I have Kronos. Kronos is another framework, but for running, it's like a cron job, a distributed cron job. So I want to run some Hadoop jobs or some cron elements. I just come into Kronos and specify them things to do, and there you have it. Here is Kronos as well. You just specify the number of jobs that you want, but it gives you a graph of your dependency, anything. So I tried to run Spark here this morning, but there's something going on with my networking, so demo are not working quite as well as I expected. So Marathon looks like this. If you want to add an application, you can do a REST call using something, or you can specify it by hand here. An ID, you process the number of CPU, the amount of RAM, the disk, you provide a command. You want to specify an executor, that's fine as well. You want to constrain how you want to run them, it's the same thing too. And here I have one application that was running, but yeah, I killed it because it was having something. But if you want to scale, well, you want to add 3 nodes, it was supposed to run, it's going to stage it, and then run it with more instances. The same thing. And now you have multiple instances of the thing running. So this is Mesos. You can see the number of slaves that you have here, frameworks, and all the elements. Now it's telling me that it's using 16 megabytes. That's because I've run another instances. And you have it here as well. These are the active tasks. I can go into the sandbox and see what's being there, mostly doing standard I/O operation, which is fun because I have a few errors going there. So this is Marathon, this is Mesos, and in the same way with Marathon, what you have to do if you want to run a Docker container, for example, is that if I come here, if you want to launch this app, for example, in Docker, you just specify something like that, and you just do a curl into this kind of thing. But my cluster is not being responsive this morning, it's not working. You just patch this request inside. Let's try this. Okay, so if I do that, yes, this you should be going inside Marathon. Just doing a curl into Marathon, and in the meantime, I should see something being deployed here. No, it's failing again. Yes, it's stalled. I have a problem with the network, but still. Okay, so let's finish up. So this was Mesos. So to conclude, a comparison within Mesos is that what you have actually with a Linux kernel, this is a simple node. What you have in Linux or something else is you have the Linux kernel or BSD or Unix, what you want. You have an init-day, upstart, systemd, that's the layer that actually run your application, start them, and on top you have your applications. You want to run Apache, MySQL, Memcache, SSHC. That's how Linux works. And that's in one node, but you want to take the same semantics and bring them into distributed computing, into a set of machines in a cluster. And this is what you can do. So instead of having the kernel below, you have Mesos. On top of Mesos, you have Marathon. On top of them, you can run any application, but this time you're not running them on one node, but on multiple machines. Instead of running a Marathon, you can run something else. You can run Aurora, like I said. Or if you can run something like this, Kubernetes. And Kubernetes, for those who don't know, is a framework actually that run multiple Docker container in a cluster way. So basically, it groups Docker containers into a group called pods, and those pods, it runs them into multiple machines. And you can take Kubernetes, run that on top of Mesos as well, because what Kubernetes needs is just specify them the amount of resources that it wants, and then it can manage itself what to run those tasks. So basically what Mesos does here is behaving like a true kernel. It's behaving like a real operating system. So it provides common services for any computer programs, whether it's Kubernetes, or it's Aurora, or it's web apps, or it's long-running jobs. That's what Mesos does. And you can see it as being a kernel for a data center, but Beyond that, you can see that as being a simple kernel to run your distributed systems. So take a look at it. If you want to try out Mesos, you can go into this thing here called Mesosphere, which is a company that provides services for Mesos. They can help you launch your own small cluster, for example. Here, if you want to launch a cluster for testing, you have a development cluster. If you want Google Compute Engine, that's for free. You can try a highly available one. We're having Zookeeper and free nodes here. You can run that's the price. And that's only the price of running inside the cloud. You're not paying for this. It's actually free for you. So if you have a voucher from Google or Amazon, you can do the same thing. You have another one. You can, if you're on EC2, you can do the same thing. There's another one here too. Yep. Where is EC2? Okay, looks like it's not working. Well, on DigitalOcean, on Docker as well, apparently EC2 has gone. But yes, these are the things you can try. You can even, if you're using something like CoreOS as well, with Docker, which is a bit crazy because you're deploying Mesos inside Docker to actually push Docker later on. Well, it's easy to try. You can install that. You have a lot of demo, a lot of tutorials here in these websites to get you started. So take a look into it and make yourself an idea. So that's all I had. I've scheduled a talk for 40 minutes and looks like I'm done in time. Okay. Thank you.